The World Space Week Association is the global coordinator for the World Space Week under the guidance of the United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, and the United Nations Office for Outer Space Affairs. Every year, the World Space Week Association board chooses a theme. This year, the theme is Satellites Improve Life. New Zealand has joined its first official space mission as a country to combat climate change. It's called MethaneSat, and the Mission Control Center will be located here in New Zealand. I'm here with Dr. Peter Crabtree, the head of the New Zealand Space Agency, and Dr. Sarah Mikalo-Fletcher, lead researcher for the mission. Kia ora, Peter and Sarah. It is a real pleasure to have you here.
Kia ora.
Kia ora.
Peter, what is MethaneSat?
So MethaneSat is a mission with the objective of sensing to, atmospheric methane concentrations, and so with the idea that we gain better information about those concentrations, and that will enable us to do, for people to make better decisions and to understand the phenomenon much better.
Why has New Zealand chosen a partnership with the Environmental Defense Fund in the US for our first official space mission?
Yeah, thank you. It's a good question. So there are two answers to that. So on the one hand, we were thinking about, prior to this, about doing something in the climate science area, and that being a really good objective for New Zealand, given our interest as a nation from a policy perspective and so on. And then on the other hand, it was an opportunity that came towards us to participate and be a partner in a really cutting edge space mission that also was going to happen within what we thought was a reasonable time frame, given the pace that we were moving at, which was quite quick. So the idea of working with an organisation that was going to be quite nimble in putting together a space mission, when sometimes some space missions can be put together over a very long period of time. And we saw this as a real opportunity for New Zealand to step into something that was really quite a serious endeavour, but something that could really assist us as a nation in quite a number of different ways.
Let's cross over to Stephen Hamburg from EDF now. Stephen, could you please tell us a little bit more?
Hello, Harry, Peter, and Sarah. It's great to be with you. And it's great to have an opportunity to talk about MethaneSat, a mission that I'm passionate about. The idea of MethaneSat started a few years ago in conversations between Steve Woofsey, a professor at Harvard University, and myself, about the need to be able to collect methane flux data, how much methane was being emitted from around the world. And we didn't have that capacity. And without that knowledge, we really couldn't take advantage of the opportunity to reduce methane emissions because we didn't know where it was occurring. So we determined what we would need from a satellite, and then went to the technology experts and asked, could we push the envelope on the technology to build the capacity and fly it in space? And while we're pushing the envelope, that technology has evolved and it is now possible, and MethaneSat is the product of that integration of new technology, innovative science, and the inversion technology that Steve has pioneered into a program that allows us to do the advocacy to bring that data to the rest of the world. And EDF, the Environmental Defense Fund, is well situated to lead this effort. EDF was founded by a group of scientists who understood a problem but didn't have the tools to implement the understanding into policy that resulted from that knowledge. And that initial problem was the impacts of DDT on birds of prey in eastern United States. So they got together and formed the Environmental Defense Fund, hired a lawyer, and then using their science went to look at and implement the needed ban on DDT, which was implemented in the early 1970s. So with methane emissions from the oil and gas industry, we understand the impact it's having on the climate, but we didn't have the tools to bring that data and understanding to the many oil and gas producing regions of the world so that we could reduce those emissions and greatly slow the rate of warming. MethaneSat is very different than many other missions in that, as I mentioned, we started with the problem and then went to look at the solutions in that could the technology provide the data necessary to address that problem. We built an amazing team led by Tom Ingersoll, who comes out of the commercial space community, of people who are really committed to ensuring that we can use space technology to help society address one of the biggest crises we've ever faced, which is climate change. And so by getting the best of the space technology community together with the best of the scientific community, and then in partnership with New Zealand, which has been an incredible opportunity to really push this mission forward fast and implement it effectively. We're very much looking forward to the operations center being in New Zealand and to getting the satellite launched and the data flowing so that we can start to figure out where those methane emissions are coming from and ensure that people understand how those emissions can be mitigated and in turn getting that job done. New Zealand is a wonderful partner in that there is a real commitment to bringing good science to bear on the needs of society writ large, and that is the mission of EDF. And so we're really very pleased to have the partnership with the New Zealand government and the science community. We're partnering with New Zealand because it's a real natural fit. The focus of the Ministry for Business, Innovation, and Employment on the use of science to help improve New Zealand society and the well-being of your citizens fits wonderfully into the objectives of this mission and to the DNA of EDF as an organization for this 50 plus years. So by taking advantage of the scientific knowledge that already exists in New Zealand and to help develop the nascent space capacity in the country, we're able to accelerate progress on the mission while developing the skill sets in New Zealand. It's a partnership that we very much value and are confident will persist and enhance the work we're doing together over the coming years.
Thank you, Stephen. I have a couple of questions for Sarah. What is novel about this satellite mission?
So many things. It's an amazing mission. I mean, for me, on the technical side, there are two big things. One is that it's the first time we're going to have a satellite flying in the sky that's going to be able to measure methane with the kind of precision we'd expect to have if someone on my team tried to measure it with an instrument on the ground. That's extraordinary. The other thing is the spatial resolution. So this thing is going to capture a 200 by 200 kilometer scene. And within that scene, it's going to do a little raster scan at very high precision. So we'll be able to pick out exactly where those emissions are happening. But then on the policy side, it's the first satellites that's really been purpose designed to support and enable climate action. So there are two big things happening there. One is that they're going to have inverse modeling as part of the whole framework, which is the modeling tool you use to go from what the satellite measures, which is the concentration, to what you need for policy action, which is to know the emissions. So that's going to be happening, live throughout the satellite mission. And then in addition to that is the impact in communicating this quickly so that we can empower people to be able to reduce those emissions.
Tell me, Sarah, what relevant expertise do we have here in New Zealand to contribute to MethaneSat science?
Well, we have quite a bit going on in New Zealand. Like, New Zealand's been a leader in greenhouse gas measurements since before I was born. In fact, when I was a PhD student coming up at NOAA, which is kind of our opposite number in the US, NIWA was already famous to me for having the best methane isotopes almost anywhere in the world. And so we have this amazing rich history of these atmospheric measurements, both on the ground and also in the total air column. So you can imagine that you have a satellite, it's flying around, looking down, trying to measure things. To make sure you get that satellite measurement right, it's really helpful to have an instrument on the ground that looks up. This is a similar type of instrument, but it's on the ground. So there's all kinds of extra things you can do to work out what you're seeing when you have something that's ground-based. So New Zealand has one of the 2 initial ground-based instruments like this. They're called TCON instruments that support all types of satellite activities, and will be supporting MethaneSat as well. And then the third big thing is the modeling, right? So we have already a well-developed modeling framework that's operating at a very high resolution, where we'll be able to be right in there with that modeling to be able to turn those concentrations that we're seeing with satellite into the emissions we need to take policy action.
The next question is for Peter. What will New Zealand get out of being part of this mission?
Yeah, quite a lot. So we get to, there's a number of elements. So one element is that the mission control for this program is going to be based in New Zealand. So we get to participate in the program from an engineering perspective, setting up the mission control functions and all the protocols around the mission control itself. So that's from, I suppose, from a space capability perspective, that's a really good opportunity for us to step into the idea of hosting a world-class space mission. So very much for the space systems people, very excited about it from that perspective. Then the other side of things is the science. And so it's really around the fact that we get to stand alongside some international partners like Harvard University and the Smithsonian and work with them on the science program. And so New Zealand's going to lead the agricultural emissions side of that, and with the US in particular focused on oil and gas emissions with methane emissions as well. So that gets us, we love the idea of international science partnerships that are operating at that level. They really help us get more impact out of our science programs. So those are those 2 elements. And then really the third bit is from a policy perspective, is New Zealand being able to make better informed decisions when we come to thinking around our own climate policies and so on.
Sarah, what are your plans for working with the Harvard team working on oil and gas industry methane?
All right, so another thing about MethaneSat we haven't talked about is that it was purpose designed to be able to tackle anthropogenic emissions, mostly from oil and gas. And that's because these are really the low-hanging fruits of climate action. If you tell people where a leak is, because it's usually an accidental leak, then you have a really good chance that those people are going to be excited to go fix that leak and reduce our methane. But there's this tremendous opportunity to be able to use the same data that are designed to be able to detect these oil and gas leaks for agricultural problems. So we also have agricultural emissions of methane from sheep, cows, rice paddies, those types of things. And the aim of the New Zealand-based science project is to develop the capability to use these data to detect those agricultural emissions, not only giving New Zealand some of the best information anywhere in the world about our agricultural emissions, but also helping to design a framework for how the international team can pick other places they might want to look at and target to support climate action there.
Peter, the theme of World Space Week this year is Satellites Improve Life. What other satellite activities is the New Zealand Space Agency involved in?
Yeah. So New Zealand's a pretty young space actor. So as we've got a space sector now, which is it's about $1.7 billion worth of activity, but we're still quite young. And so in terms of satellite development, a lot of our effort is going into largely educational institutions, probably smaller scale satellite programs, CubeSat opportunities, which start to, on the one hand, demonstrate what you can do with small satellites as a capability, and the things you can do with small satellites are every day, like miniaturization across all technologies is that it's ever expanding. We're also really interested from a government perspective as what are the government's needs that can be better addressed through satellites. So that is, and so really at the moment we've got spending a lot of time across government working with lots of agencies that have an interest in, and have for a long time often used Earth observation, but it's really about the New Zealand government being a super user of satellites. And I think over time that will lead us to getting clearer about which areas we want to invest in particular when it comes to the satellite capabilities. So we're on a journey at the moment.
And would you like to see New Zealand making greater use of satellite data?
Yeah, absolutely. And I think it's quite a challenge for a lot of people who have not been exposed to the possibilities of this. And there are lots of things that we do that at the moment we might be on Earth and we might measure in certain ways, and it's quite labour intensive and resource intensive. But also, the issue around frontier technologies like this is that they push the boundaries of what might be possible. So so what if from space you could every day you could track, or every week you could track about whether we were winning the battle against possums in our conservation estate, and suddenly on your desktop you've got machine, AI robots essentially being able to tell you that those species are thriving or not thriving. And so we're interested in that. We're seeing those kinds of possibilities all over the place. And I suppose it's a question of getting in a sense, the customers or potential users to understand that that is a real possibility. And on the other hand, that we fast track our technology development so that we can actually give people these types of solutions. It's really, really exciting time.
But this is what World Space Week is all about as well, bringing space technology here to people on Earth. So we are on a very good path.
Yeah, absolutely.
Well, thank you very, very much, Peter and Sarah, for your time and for coming here, and happy World Space Week.
Thank you.
Thank you.